Question 1 says, find the force of repulsion between two electrons held 1 meter apart in a vacuum. So to do this, we're going to use the equation that the force is Q1 Q2 over 4 pi epsilon naught r squared. So there's 2 electrons, so on the top we need the charge of the electron, which is 1.6 times 10 to the minus 19. That's one of the 2. We're then going to multiply it by the other one, but the easy way to do that is just to square this term and then divide this by 4 pi. When you type this into your calculator, you need to be a bit careful, because if you type in 1.6 times 10 to the minus 19 squared divided by 4 pi, it doesn't automatically bracket this 4 pi. So what it will actually do is divided by 4 times pi, and because of the order of operations on calculators, or certainly on older calculators, it will do the divide first and then the multiply. So if you just type it in like this, while you want it to read it with the brackets here, actually sometimes on older calculators it reads it with a bracket here, which obviously gives you the wrong answer. So that's just something to look out for when you're doing this. Times epsilon naught, which is 8.85 times 10 to the minus 12, multiplied by their separation squared. Well, their separation here is just 1 meter, so 1 squared. If we work out this value, it should be 2.3 times 10 to the minus 28 newtons. Find the gravitational force of attraction between them. So this is what we had been doing previously, minus g m over r squared. So g is 6.67 times 10 to the minus 11, multiplied by the mass of an electron is 9.11 times 10 to the minus 31. Again, it's 2 electrons, so we could multiply by that again, but instead we'll just square it, divided by the distance between them, which again is just 1 squared, which is 5.5 times 10 to the minus 71 newtons. So very small, unsurprisingly, 2 small masses. Find the factor by which the electrostatic repulsion is greater than the gravitational attraction. So we're going to do Fe over Fg. So it's 2.3 times 10 to the minus 28 over 5.5 times 10 to the minus 71, which is equal to 4 times 10 to the 42. So the electrostatic repulsion is much bigger than the gravitational attraction.